Okay, let's go. Quad tutorial number 19, kind of a hodgepodge of a lot of different things. And let's start. Number one says use one of the solving methods to find the x-intercepts of the following quadratic. We know that when we talked about factoring with quadratics that we were finding the x-intercepts. And so what are the steps to find them? Well, the first thing is to remember what an x-intercept is anyways. An x-intercept are going to be all those points that are located on the x-axis, right? And what do all the points on the x-axis have in common? You got it. Every single point, like this is 1, 0, that's 4, 0, this is negative 3, 0. Every single point on the x-axis has a y that is equal to 0. So that's why if we're interested in finding the x-intercept of a quadratic equation, we would go ahead and set the y equal to 0. So here we go. We're going to set it equal to 0, and then we're going to realize when we solve for x, we're going to find where our x-intercepts are. And so we recognize we have a quadratic, and that we're going to, and it's a trinomial, and so we're going to set up our two parentheses, and we'll factor. We'll think of two numbers that multiply to equal negative 30 and add to equal negative 7. When I think of 30, I think of 1 times 30. That's not going to work. 2 times 15. Nope. 3 times 10. Ooh, that has some potential, right? We know it's going to be a 10 and a 3. We know that one of them has to be negative because the middle term is negative 7. That means my 10's got to be negative and my 3's got to be positive, right? Let's double check that. Negative 10 times 3 does give me negative 30. Negative 10 plus 3 gives me the middle term of negative 7. So that is correct. We have factored it correct. And then we're going to use our product, multiplicity product of 0, which says that if we have something times something equals 0, that means that x minus 10 equals 0 and x plus 3 equals 0. So let's go ahead and solve for x, and we see that at x equals 10 and at y equals negative, sorry, where the y came from, and at x equals negative 3, we have x-intercepts. So that means that if we were to graph them, we would see 1, 2, 3, at negative 3, and 1, 2, 3, 4, 5, 6, 7. All right, you get what I mean. At negative 10, which would be way over here, there'd also be a point. So if we want to enter this officially, we would say our 2 points are 10, 0 and negative 3, 0. So how do we find the x-intercepts of a quadratic? Step 1 is setting the y equal to 0 because all points on the x-axis, all x-intercepts have a y equal to 0. And then we solve for x. And in this case, we're factoring a trinomial to solve for x. All right, use one of your solving methods to find the vertex of the following quadratic. Well, we've done this a million times, it feels like, right? We know that to find the vertex, to find the x part of the vertex, we set x equals to negative b over 2a. In this instance, b is 12, so that means it's going to be negative 12, and a is 1, right? So negative 12 divided by 2 is going to give me a negative 6. So to find my vertex, there are two parts, right? We know this. The negative 6 is the x part of my point, but a vertex is a point that needs both the x value and the y value. So we're going to switch it up, and we're going to find the y value, which a better way of saying that is we're going to find f of negative 6. We are going to figure out what this function is equal to when x is equal to negative 6. So we're going to plug in a negative 6 everywhere we see x, and we're going to pick up our calculator, which I need to pick up mine. Let's see, so we'll have 36, and then we'll have a, let's see, 12 times negative 6 is going to give me a negative 72. So we've got, so I'm kind of doing it in my head and with the calculator. So we have negative 72 plus 36, which is, of course, negative 36, plus a 25 gives me a negative 11. Hopefully you agree with me here. So negative 11 is our y value for our vertex, and there we have it. How do we find our vertex? We use negative b over 2a to find our x value, and then we plug that x value in to find the y value. Okay, solve this system algebraically. So we see that we're given a quadratic and we're given a linear in standard form. And so I notice that I've got y equals all of this stuff over here, which just gives me an idea, right? Because remember when we solved systems, linear systems back in first semester, we used either substitution or elimination. And so elimination is not going to work when we have a quadratic and a linear. It's just not going to work. Substitution is going to be the only thing we can do. And so this first equation tells us that y is equal to all of this stuff, which means that in the second equation, when we see y, we're going to substitute in all of that stuff for y. And in that way, we're merging the two equations to see where they have an overlap, right? Where their solution is. So we're going to rewrite the second equation, 4x minus 2. And when I see the y, instead of writing a y, I'm going to plop this whole thing in, and I'm going to use parentheses to hold it all in. That's really important. So notice I just took the second equation, and the only thing I did was instead of writing the y after the 2, I plugged in the right side of the first equation. So now this is really important. The first thing is that we use parentheses when we are plugging in. And the second thing is to realize that we are distributing a negative 2. So I'm going to bring down that 4x. I'm going to distribute that negative 2. So that's negative 2x squared. That's going to give me a negative 6x. And that's going to give me a positive 20. I'm going to go ahead and combine my like terms on the left side, and I'm going to get them in descending order. Right, I'm going to have my negative 2x squared be first, and then I have 4x minus 6x gives me a negative 2x. So I'm combining those two like terms, and I'm bringing down my 20. And now I want, because to solve a quadratic, we've got to have a 0 on the left side, or I'm sorry, the right side, one of the sides, in this case, the right side. So we're going to go ahead and get rid of the 8. We're going to subtract the 8 from both sides. And we'll say negative 2x squared minus 2x plus 12 equals 0. It looks like we're ready to factor, right? We've got the quadratic on the left side, we have the 0 on the right, but gosh darn it, we've got something that's stopping us from finding success, and that's that negative 2. We can factor with a coefficient in front of the x squared. I mean, we always have a coefficient in front of the x squared, 1, all right, but we just don't see it. But when we actually see a different number than 1, we could factor, but we're going to do a shortcut to make this easier. We're going to get rid of that negative 2. And how we're going to get rid of it is we're going to divide every term by negative 2. So think about it. If I divide this term by negative 2, boop, that goes away, our problem goes away. But we just can't divide negative 2 by one term. We have to do it by all the terms. Otherwise, we're going to end up with an equation that's no longer true. It's no longer balanced. All right, so we'll have that x squared. The negative 2's cancel out here. That leaves me, so the negative and the negative make a positive. Leaves me with a positive x, and then 12 divided by negative 2 is a negative 6, and 0 divided by negative 2 is 0. And now we are setting ourselves up for success, right? Now we can go ahead and factor the left side, finding two numbers that multiply to equal negative 6 and add to equal positive 1. So we know we've got a 3 and a 2 involved, right? Certainly a 1 and 6 isn't going to help us. Who needs to be positive? Who needs to be negative? That's right. The 3 needs to be positive. The 2 needs to be negative. 3 times negative 2 does give us that negative 6. 3 plus a negative 2 gives us that 1x, that middle term. And then we're going to go ahead and set each of our factors equal to 0 and solve for x. Subtract 3 from both sides, so x is negative 3. Add 2 to both sides, so x is 2. And what did this question ask us for? It asked us to find, or to solve. So our solution, when we think about, going back to linear systems, and we think about our solutions always are going to be a point, right? Or sometimes there's no solution, sometimes there's infinite solution. But in this case, we're actually going to have 2 points as our solution. And we'll find out with the next problem we graph why sometimes when we are looking at the graph of a quadratic and a linear, that we'll have them intersect at 2 points. So we do. When x is equal to negative 3, there's an intersection, and when x is equal to 2. But we can't stop there, right? We know that there's a point that starts with negative 3 for x and a point that starts with 2 for y. Now we've got to find what's the y value when x is equal to -3. Believe it or not, I'm going to use the quadratic to find out. I'm going to plug in the -2, wait, what was the first one? -3. So I'm going to find f of -3. I'm going to go ahead and plug in that -3 every time I see an x. And let's see if we can do this in our head. We're going to have 9 minus 9 minus 10. So we know that f of -3 is going to be -10. Let me just double check my work. That looks good. All right, so that's going to be -10. So that's one of our points of intersection when if we were to graph these two functions. And then let's go ahead and find f of 2. So let's switch up a color so we can see what I'm doing. I know that 2 is the x value for one of the solution points, and I'm going to go ahead and find f of 2 to find my other point. All right, let's see. Let's do this in our heads because I don't have a calculator with me. I've got 4 plus 6 minus 10. Well, 4 plus 6 is 10. 10 minus 10 is 0. So when we plug in 2, we are going to get 0 for y. And there we have it. The solution of this system, a linear and a quadratic function, is -3, -10, and 2, 0. If you wanted to take the time to actually graph these two functions, you would see that they intersect each other at these 2 points. And now we're going to solve the system graphically. Once again, we're looking at a similar problem. We've got a quadratic, we've got a linear equation. Let's go ahead and graph. I'm looking at the quadratic, and I know I can't use transformations because there's more than one term that has an x. So I'm forced to find my vertex using -b over 2a. So negative b is -4 over 2 times 1. So that's a positive 4 divided by 2, which is 2. So our x value is 2. To find our y value, we're going to go ahead and find f of 2, right? We're going to plug in 2 every time we see an x. And let's see, that's going to give us a 4 minus an 8 is -4 plus 2 is -2. So our vertex is at 2, -2. I'm going to go ahead and graph that. And let's go ahead and take the time, continue with graphing this quadratic, and make our table looking at things that are 1 away from the vertex. So I'm going to look at when x is 1. I'm going to plug in 1 every time I see my x. Will have 1 squared minus 4 times 1 plus 2. So that's going to give me what? 1 minus 4 is -3 plus 2 is -1. So I'm going to go ahead and graph that. 1, -1, and that means that if I go to 3, I'm also at a -1. Let's do another one. Let's see what happens when x is equal to 0. That's 2 away, right, from the vertex. When I plug in 0 for x, end up with 0 squared minus 4 times 0 plus 2, which is just a lot of zeros, right? 0 minus 0 plus 2 is 2. So I know that. I'm going to go ahead and plot that. When x is 0, y is 2. And when x is 4, y is also 2. And I think that's going to be enough. I may have to come back and do some more points for the quadratic if we can't get a clear intersection with the line. But right now, I'm going to go ahead and connect these 5 dots so that I see that I have a clear quadratic before I move on to graph my line. I'm going to use red to graph my line. We know this is in slope-intercept form. -6 is our y-intercept, so we put our dot there. And 2 is our slope, so we know we rise up 2, we run 1. Rise up 2, 1, run. I'm going to keep doing that until I hit a point. Rise up 2, run. Oh, this is nice, right? We just hit our, oh, we hit it twice, didn't we? All right, let's keep rising up. So we can see that we have 2 points that are intersections. So let's go ahead and graph that little. All right, I'm going to use a different color to highlight. Let's go with, how about a bright green. This point right here, so this point is over 4 up 2. Okay. And this point right here, which is our vertex, right, which is over 2 down 2. These two are our points. So on the test and in your practice, it's enough to just circle, hey, here's where they intersect. If you want to go the extra mile and write them out, write the 2 points out like I did, that's fine. I'm going to be looking for a clear graph where you can see where you can find two corner points that actually are on both the line and the quadratic. All right, once again, you know that practice makes perfect. I look forward to working with you on your marker boards, and continue to work with your partner and check your answer when you work on the practices. I think that's the last one. Yay, thanks for joining me.